All right, so today we are solving quadratic equations with square roots, and we're going to be able to simplify square roots, and we're going to learn about imaginary numbers. We're going to start with vocabulary. So you know that this is a radical. Sometimes you call it a square root, but the thing is, it's only a square root when the index is 2. This one has a name too. It's called radicand. And you may have seen a cube root before. So the cube root has a 3 here. This is called the index, this little number. Now when we do a square root, we don't see an index in it. They don't put a 2 for a square root. So when there's no index, then it's assumed that it is a square root. Which means n equals 2, square root. All right, so that's just vocabulary. I'm going to give you a minute to make sure you got it, and then we're going to go over this example, but please feel free to preview it right here. So you have probably simplified a problem like square root of 32 before, but it's been a while, and so we're going to review it. What you want to do is you want to break it into its prime factors. So you can break 32 into any two numbers that multiply to make 32, and then you continue breaking up any number that can. So 2 times 16, 16 is 2 times 8, 8 is 2 times 4, and 4 is 2 times 2. So 32 is 2 times 2 times 2 times 2 times 2. And then when it's a square root, you look for pairs, because the square root of 2 squared, the square root and the square cancel, and you can move that number out. So here, this 2 and 2, it comes out as a single 2. And this 2 times 2, it also comes out of the radical as a single 2. And then the last 2 is left underneath because it doesn't have a partner. And then on the outside, we have 2 times 2, which makes 4. So when I ask you to simplify the square root of 32, it should be 4 root 2. All right, so we'll do one together. Let's just do the first one together. Okay, 48. Can you give me any two numbers I can multiply to make 48? 12 and 4? Good.
24 and 2.
It could be that too. So you can do it with 24 and 2. I'm going to do the 12 and 4 because it was the first one I heard. But you can also, you can do any of those combinations, okay? Then you break up the numbers that you have. So my 12, I'm going to make it 3 times 4. And then this 4 is 2 times 2. Good morning.
Good morning.
And then this 4 is 2 times 2. So we're going to use anything that is at the bottom of the tree. So at the bottom of the tree, I have 3, 2, 2, 2, and 2. So those are the numbers I'm going to put inside my radical. Because they're not at the bottom. So see how there's something underneath the 4s?
No, the 4 next to the 2.
That one? Because if you look at that 4, underneath it there's 2s. So only the things that are at the very bottom. It's a good question. Okay. So then I'm going to make the radical, and I'm going to put all these numbers underneath it. 3 times 2 times 2 times 2 times 2. And then you look for the pairs. So you can circle your pairs. The square root of 2 times 2 will come out, and the square root of 2 times 2 will come out. And they move to the outside. Bless you. So notice that pair becomes a single 2 on the outside because I took its square root. That pair becomes a single 2 on the outside. And then I multiply those two together to get 4 root 3, and I'm done. Okay. Actually, we're going to do 2 together because that one's interesting. What's the square root of 64?
8.
Is he right? Is it 8?
Yeah.
Yes, right? So if you know the square root is an integer, you don't have to make a tree. Like the square root of 64 is just 8. Okay? So when you see a square root problem, start by trying to figure out like do I actually know that answer? Do I have to make a tree? But if you don't, that's when you make a tree. So do problem 3 right now.
Where is that?
So 27, 9 times 3.
Buy some cheese.
Focus, please. And then 9 is 3 times 3, so you should end up with 3 3s. And then we have square root. 3 times 3 times 3. And then we're looking for pairs, so you're going to circle any pairs. And that comes out as a single 3. Square root of 3 times 3 is 3. This one doesn't have a partner, so he stays under. Like that. Okay, check your work, make sure you have it, because we're going to do 4 next.
Wait, so how about 1? Where did the other 2 go?
Which one?
For number 1, where did the other pair of 2s go?
So this pair of 2's came out as a single 2. Remember, 2 times 2 is 4, right?
Yeah.
Square root of 4 is 2. So when I do the square root of that, I just get the first 2. And then when I do the square root of that, I get the second 2. Okay? All right, number 4. What are 2 numbers that multiply to make 54? Could be 2 and 27. What else did you guys use? 9 and 6? Yeah. So you can use either of those. It's up to you. I'll do the 9 and the 6. And then that's going to give me 3 and 3 and 3 and 2. Okay. So, looking for pairs, they have to be under the radical, so those 2 don't count. But I do have 2 3's that can pair up. Square root of 3 times 3 is 3, and that's going to come out. So that gets me 3 times 2 on the outside. That one comes down. And then the square root of 3 times 2. And so both of those will make a 6, so it'll be 6 root 6. Okay. Make sure your notes are complete, and then you can turn the page. All right, so we're going to use square roots to solve equations now. And you can solve square roots when the square term contains the only x's. So if you think back to the problems that we solved by factoring, they had an x squared and they had an x, so you weren't able to solve those with square roots. Here we go. All right, so here we only have one term that's squared, and that's where our x is. And so we can isolate the squared term by dividing by 3 on both sides. This is 3 times the squared term, so we divide. Okay. 54 divided by 3. What are you guys getting? 5. Did you say 5? 54 divided by 3. What is it, guys? 18? Yes? Okay. All right, then, the inverse operation of squaring is square root. So to get rid of this square right here, we've got to do a square root on both sides. Now, when you solve with a square root, you're actually going to get 2 answers. Do you remember that when we solve with factoring, we always got 2 answers? We had 2 factors, and each one gave us an answer. It's the same thing when you solve with a square root, and here's where it comes from. If I tell you that a number squared equals 25, that number might be 5, right? Because 5 squared is 25, or it might be what other number? What other number can multiply it by itself to give you 25? What's that? So 5 times 5 is 25, right? Positive times a positive?
Negative.
Yes. Negative 5 times negative 5 is also 25. So if I tell you that a number squared is 18, my answer might be the positive root of 18, or it might be the negative root of 18. So in front of your root there, you need to put a plus or a minus. This is where we're going to get our two answers from.
I know one to put a plus and one to put a minus.
You put them both, because they're both answers. So we're going to find two answers, plus and minus, okay? Now on the left side, the square root and the square cancel out. So I have just x minus 1 equals plus or minus root 18. And then I have to still get the x by itself. So to get the x by itself, I need to get rid of that minus 1. So what would be the inverse operation of minus 1? Plus 1. And here's how your answer is going to look. Well, actually, it's not completely done, but it's going to have this format. 1 plus or minus root 18, which means one answer would be 1 plus root 18, and the other answer would be 1 minus root 18. The reason it's not done is because we can simplify the radical root 18. Was that one that we did on the front? Did we do root 18 already? I don't think we did. So we're going to make that factor tree for root 18, and then we're going to figure out what that would be. I'm just going to do it on the side. So 18 could be 9 times 2. And 9 is 3 times 3. So those are my numbers. Square root 3 times 3 times 2. Those will come out, and so 3 root 2. So going back to our problem here, we're going to replace root 18 with 3 root 2. So x equals 1 plus or minus 3 root 2. All right, that was definitely one of the harder problems, although it wasn't one with imaginary numbers in it. I don't know if we're getting into imaginary numbers today. I thought we were. Okay, that's fine. Hi, Joyce. All right. You guys ready? We're going to do 1. How do I get rid of my square root? Or am I squaring? I'm going to square root. When I square root both sides, what do I need to put in front of my root?
Plus or minus.
Plus or minus. Thank you for paying attention. Do I need to make a factor tree for root 36? I could make a factor tree, but I don't have to because what? I already know it, right? Root 36 is what? It's 6. So my answers are positive 6 and negative 6. I'm going to pause here and have you guys try a few problems. Start with 2. Go in number order. Use these 2 examples. All right, here we go. Ready? Good. So we're going to start by undoing the subtraction with addition. And so you should get 40 there. And then you're going to undo the multiplication by dividing by 5. And then how do we get rid of the squared? Square root. When we do a square root, remember we need a plus or minus in front of it. So there's my square root, and then I have plus or minus square root. So x is equal to plus or minus root 8. Now root 8 can simplify. So you're going to do a factor tree. 8 would be what times what? Could be 4 times 2. And then the 4 is 2 times 2. So there's 3 of them. That's what you're asking me about, right?
Yeah.
So 8 is 2 times 2 times 2. So I guess I'm going to use the space over here for that. So I have x is equal to plus or minus square root 2 times 2 times 2. And these two can come out. So the square root of 2 times 2 is 2. So I have plus or minus 2 root 2.
Stop doing it, bro.
When you ask me to stop, I will never stop.
3, the square term is already isolated, so this time, because the square term is isolated, we're going to square root first. Remember your plus or minus when you square root. What is the square root of 81? It's 9. So we didn't have to make a factor tree for this one. It's just 9. Now, we actually now have 2 equations to solve because it could be 9 or it could be negative 9. So we're going to write them both out and solve each one.
Wow. Oh, wow.
All right, and once we've done that, that's not hard. You can solve that. Subtract the 1.
Why was this question interesting?
It's interesting because we had to write 2 different equations. But thanks for asking.
Thanks, Joseph.
All right, so that one gave me x equals 4. This one, I'm going to subtract the 1, and I get 2x equals negative 10. And divide the 2. And this one gives me x equals negative 5. So when you get the plus or minus, and you just have plus or minus an integer, you can just solve the 2 equations that way. All right, I want you guys to try a few more problems and check with your neighbor on your answers. I think I'm on freeze. Let me unfreeze. Okay. You need to isolate the squared term, so you're going to get rid of the plus 1 with minus 1. And you get 12. I saw a lot of you got to 12, which is good. Okay, in the next step, we have to get rid of the squared by square rooting both sides. And you need to remember the plus or minus on your root 12. So we have plus or minus root 12. My square root and my square cancel, so I have just x plus 5. I'm going to get rid of the plus 5 with a minus 5. The most important thing you need to know is that it can't combine with the root 12 because it's not under a root. Some of you have written plus or minus root 12 minus 5, and that is acceptable because it's mathematically accurate. However, it's more often you're going to see the negative 5 come first, and then the plus or minus root 12. All right, so if you had plus or minus root 12 and then minus 5 afterwards, that is mathematically accurate, and that's fine. You're just going to see it this way more. And then finally, I have to make that factor tree for root 12 so that I can simplify that. So I'm going to do that on the side. My root 12 is there. 4 times 3, 2 times 2. So I have the square root of 2 times 2 times 3. Those are my pair. They'll come out to make 2 root 3. So my final answer here is going to be negative 5 plus or minus, and instead of root 12, 2 root 3. All right, what questions do you have? All right, I'm ready. Go ahead. What's next? Mm-hmm. Good. Oops, minus, right? Then what? Then you square root. Try to keep up, guys. Okay, so then on the left side, I would have x minus 3. And then what do I have on the right side? Good. What is the square root of 16? Right. Okay. All right, so when we end up with something like this, x equals 3 plus or minus 4, we're actually going to get two answers out of that. Because we can add those. Those are like terms. So first one, 3 plus 4, what do we get? 3 plus 4?
Yeah, 3 plus 4.
What is it? You can say it.
No, I want this one because he's explaining the problem.
Does anybody want to tell me what 3 plus 4 is? Thank you.
Good job.
And then 3 minus 4? All right, guys. So, two answers, 7 and negative 1. They don't have a radical in them this time because the square root of 16 was just 4. So sometimes your answer will have a radical, sometimes you'll just have integer answers, but you still get two answers no matter what.
Good job,
Where
Ozzy.
did you get negative ones?
3 minus 4. Does that make sense? Does that make sense? We did 3 plus 4 and then 3 minus 4.
Because
No, it's not.
square root of 16 is just 4.
Yep.
Pretty cool.
Nah.
All right, problem 6, we have a fraction to get rid of, and there's more than one method. Raise your hand if you can share one method for getting rid of that 1/2. I'm looking for some hands this time, because I know there's more than one way to do that. Ahmed, did you want to share a way?
Yeah, I think he wants to share.
How could I get rid of the 1/2?
You could multiply by 2.
I could multiply both sides by 2. Was anybody else thinking that would be how you wanted to do it? Multiply by 2 on both sides? All right, I saw that. Good. Anybody have a different method? What's another way I could get rid of the 1/2? Ryan? Were you raising your hand?
No.
Okay. What's another way I can get rid of the 1/2? If the 1/2 is being multiplied by the parentheses, how do you undo multiplication? Divide it, right? So you could multiply both sides by 2 or divide both sides by 1/2, and you should get the same answer. People forget that dividing by a half actually makes things bigger. Dividing, if you do 9 divided by 0.5, you should get 18, because there are 18 halves in 9. But I'm going to use Ahmed's method because it just looks nicer, right? Times 2 times 2. 2 times 1/2 is 1, so that cancels. And that's going to give me 18. So I have the square of x minus 8 equals 18.
What?
And now all my steps are the same. I'm going to simplify the square by square rooting both sides. Don't forget your plus or minus.
There's no square root for 18.
And then how do I undo the minus 8?
Oh, wait, add 8.
Add 8, good.
What?
I feel like we've already simplified root 18 somewhere. Oh yeah, it's on the top of our page. So we already know root 18 is 3 root 2. I'll show you where we did that in a second. In the example problem, you remember we did root 18? So these were all your steps to simplify root 18. We got 3 root 2, so we're going to reuse that. We don't have to do that work again.
Toss him in the plastic room.
You, boo.